Good afternoon, everybody, and thank you for joining me for another video. Joe here with Tufel Gun and Armory, and today's video is going to be on drill bits and precision drilling. This is a timed assignment for SDI's MAC110. So my name is Joseph Marshall. It is August 2nd, 2026, right around 5:45 p.m. And let's get started. The first part of this video is really brief, but there's a lot to it. We're essentially going to be drilling two holes exactly an inch apart onto our blank. So there's some preparation. First, you want to put some layout dye on it to allow the scribe marks to dry. You're then going to take your caliper and you're going to measure exactly how big the blank is. And from there, you can calculate what an inch looks like. Once you have those measurements scribed into the workpiece, then you take a center punch and center punch those two spots. Secure it into a vise or some other means of securing it. That way it is secured and ready to be drilled, and then comes the drilling. Here is the layout die applied on our workpiece. Here we have everything scribed out on our workpiece. Here we have our workpiece center punched. Here we have the workpiece secured on the vise. The reason why I use the vise as opposed to something else is it gives you a lot of space underneath the workpiece for that bit to go through instead of into your workbench. And also, being that aluminum is so soft, the steel plates on both sides will dig in and really hold it. And as you can see here, center to center is exactly 1 inch. So how did I get these measurements? Well, first, I measured the overall length of the blank in the caliper, and that came out to 4 60/60 of an inch. Then I divided that by 3 and put the answer of 1 353/1000 of an inch into the caliper and scribed the first line. Then I added an inch, so 2 353/1000, and I scribed the second line. Then, just to double check my work, I put an inch on the caliper and measured between the two lines. Once I made sure that it was correct, then I got to center punching. Center punching does two great things. One, it gives you a better visual on where you need to drill. And two, it helps stabilize that drill bit when you're first starting that hole. That way the drill bit doesn't jump and move all over the place and throw off your precision and the cleanliness of the hole. Now let's talk about the pros and cons of different machines that you could use to complete this task. We're going to get into cost effectiveness, amount of training required, and generally speaking, what each is used for, and the pros and cons of using them as the other. The pros of using a hand drill versus a drill press or a milling machine come in cost effectiveness and user friendliness. However, the major con to this is everything's manual. You have to manually control the bit speed and the feed rate when using a hand drill, whereas the drill press and the milling machine are automated and you set the settings and go. Now, moving on to the drill press, this is a happy medium between the two other options. The pros of using a drill press compared to the other two are its design and speed of repeatability. The drill press was designed to be able to quickly and efficiently drill vertical holes into a workpiece. However, the con to this is you are confined to one bit, much like the hand drill. The major pro of the milling machine, on the other hand, is the fact that it incorporates multiple bits and is able to carry out multiple tasks on the same workpiece at the same time. However, the cons to this are its cost ineffectiveness and it being the least user-friendly out of the three. For this project, I chose the hand drill because the only real precision I needed was making sure that the holes were drilled the correct distance apart. If I was working on an actual firearm or some other project where I needed a much higher level of precision, I would go with the drill press for its speed and repeatability, because I would be able to drill multiple holes of the same type a lot faster and a lot more precise, because I would be able to control the bit speed and the feed rate more efficiently than I would just using a hand drill. Now let's talk about the relationship between bit speed and feed rate. It is important when you are working on a project to have all of these things aligned. If your bit speed is too fast or too slow for your feed rate, or if your feed rate is too aggressive or not as aggressive enough as your bit speed, it could lead to a myriad of problems, to include burning of the workpiece, structural degradation of the workpiece, damaging of your tools, excessive wear, a myriad of things. You'll have uneven cuts, and any number of things. So
what you're looking for, according to this week's lecture, Module 2, is one long, non-burned, even strand. This lets you know that your bit speed and your feed rate are aligned and you're cutting evenly and uniform. 3 specific signs that something's wrong with your drilling process are unusual chip characteristics, excessive heating or smoking, and unusual sounds or vibrations. Now, let's get into it. For chip characteristics, it has to do with your bit speed. Either your bit speed is too fast or too slow for your feed rate, and you're removing too much or too little material and not getting the long, even, uniform, non-burned strands of material being taken off. For excessive heat or smoking, this has to do with feed rate. This is a telltale sign that there's too much friction on your workpiece and it is burning your workpiece and damaging, wearing out your bit too excessively, and you need to lay off that feed rate a little bit. Unusual sounds or vibrations also has to do with feed rate. If there's too much pressure, it's going to hinder that bit from spinning as fast as it's set to. And if there's not enough friction, then that bit speed's going to move freely and it's not really cutting anything. 2 specific signs that your drill bit is not hard enough for the material that you're cutting. The first one is pretty simple. If you're drilling on your workpiece and it's not biting or it's walking across the surface and not digging in, that's a clear indication that the material is too hard for the bit. Now, if you're looking at the tip of your bit and you see it's shiny, discolored, looks rounded, then that means that the tip of your drill bit has become dulled and is not able to grasp onto anything. Now, one could argue that that is due to improper maintenance on your drill bits, but it wouldn't have gotten that rounded or that dull unless you were trying to drill into something that your bit is not supposed to be drilling into. So that's why these signs indicate a hardness problem versus any other kind of problem. If I'm drilling a hole and I'm finding that my bit isn't cutting correctly or efficiently, I'm going to stop what I'm doing and take a look at my bit. And this will help me decide whether it's a hardness issue or a dullness issue. If I look at the tip of the drill bit and I see that it's rounded or mushrooming or discolored, or if the edges of the cutting edge are chipping, this could be a sign that it's not hard enough to drill through the material that I'm using, and it's just rubbing on the top, causing that friction and heat. On the other hand, if it's a dullness issue, you're going to look for a lot of the same things, but from the side. If the sides look polished, like they're just rubbing around in a hole and not actually cutting anything, then that's an indicator that your bit is getting dull. You could also look at it at an angle and actually see the cutting edges and look for deformations in the cutting edges. And this will tell you that it's a dullness issue. A way to double check this theory is move from the material that you're working on currently to something that's known to be softer. And if you're still having the same issues, then it will be a dullness issue versus a hardness issue. One harder drill bit that's commonly used in gunsmithing is cobalt drill bits. Cobalt drill bits are a lot harder and stronger than regular high-speed steel drill bits, and they are commonly used for cutting harder metals like stainless steel that high-speed steel just won't cut into. Some of the disadvantages of cobalt bits are brittleness and cost. Generally speaking, if you can use a tool for more things, it's going to cost more, and cobalt definitely fits that bill. Now, as cobalt gets heated and loses its heat temperament, it becomes very brittle. That is definitely a downside. It'll start chipping more and losing its capability to do its job. One specific application where a cobalt bit is the correct choice is when you have a stainless steel barrel on a lathe and you're wanting to cut flutes into said barrel. The part of a drill bit that needs to be ground while sharpening are going to be the cutting edges. Now you have cutting edges and then you have relief angles, and the non-cutting edges are going to be at the end of those relief angles. Let me show you what I mean. So you have these edges right here. These are going to be your cutting edge, and this is going to be your non-cutting edge. And you can tell them apart because you can actually see where that relief angle starts because the light hits it different. And so you're going to want to sharpen that cutting edge and leave the back one alone, going all the way down the length. Now on the top, you're going to see the same thing. You got your cutting edge, and then you can see where the relief angle starts, and that other edge does not need to be cut. Same with on this side. You got your cutting edge, and then the relief angle and the non-cutting edge. And so those are the areas that you need to grind when sharpening. And proper grinding restores cutting ability because it brings these cutting edges back to being sharp. Maybe not quite as they were directly from the factory, but brings them back to a level of sharpness that'll restore the cutting ability, and those relief angles will still be defined, which will help dissipate that heat, so you're not overheating your bit. And that brings us to the end of this video. If you like this video and want to check out some of my others, feel free to visit my page and go ahead and hit that subscribe bell. It's the best way we grow together, and I'll see you next time.